All right. Hello, guys. So, welcome. Today, again, we're going to be doing the AMC 8, right? Some practice problems. And today we're going to be focusing on the 1995 AMC problems. And how it's going to work is just like how we usually do. I'm going to go over some of them, about four or so at a time. I'm going to set it out, give you guys 10 minutes to work on them. And then afterwards, we're going to go over all of the problems. And then one by one, and then I'll give you guys about 1 minute to explain your solutions, and then I'll compare it to the AMC solution or the fastest way. All right. And remember, like what we've said before with the AMC 8, it's always important to find the fastest solution. So make sure you focus on that today because there's always multiple solutions to a problem, right? But some of the solutions that you may find are going to take way longer than the correct solution. So just make sure if you see a calculation that might take you a really long time and or might take you a calculator because calculators aren't allowed, then you most likely should use a different strategy or a different approach to the problem. Okay. So we'll get started. Here is the first problem set, 1 through 4. And I'm going to leave it out, give you guys about 10 minutes to do it. And then after 10 minutes, we'll go over them. Okay. So make sure you pace yourself and you can begin. For you two that just joined, we've started on these first 4 problems and I'm giving you guys 10 minutes to do it. So, yeah. And I'll update you guys when there's about 5 minutes left. Okay, I'm gonna give you guys about 5 or 4 more minutes. So if you haven't moved on to problem 3, you should try maybe move on if you're stuck on a problem. That's okay, Ricky. We're just going over the first 4 problems. So you have a little bit less time, but try to complete them. You have about 4 minutes.
你说他家在这个深圳，没看明白。那我跟他说，我说等孩子那个下来，我再跟那个我给你看的没好，你还哭什么啊？
Let's do 1 more minute. All right, guys, a couple more seconds, finish up. And what you can do is you can start sending your answers in the chat if you want. I would start with problem 1, so don't send all of them. If you want to send it directly to me, that's fine. If you want to send it publicly, that's also fine. So just send your answer to problem 1, and then in a second, we can have you guys unmute, or you can type your solutions in chat. And if you want to, there's an annotate feature, if you know how to use it, and you can try drawing. But cool. I've gotten some responses, so we're going to start with problem 1. All right. So the question here is, Walter has exactly 1 penny, 1 dime, or 1 penny, 1 nickel, 1 dime, and 1 quarter in his pocket. What percent of a dollar is in his pocket? All right. So usually on the AMCs, as we know, the first few questions are always the easiest, but we should always follow the strategy, which is identify what we know and identify what we don't know or what we want to know. So what do we know? Well, we know how many pennies or how many coins of each he has, right? And we know the amount of cents that these take up. So I'm just going to write out these. So a penny is 1 cent, pretty clear. So we're going to put 1 plus a nickel, 5 plus a dime, 10 and a quarter, 25. And then we can add those up and we would get 41. So the question is, what percent of $1 is in this pocket? So what do we want to know? We want to know the percent. And when we're dealing with percents, usually what we end up with is either, a percent sign with a number in front, or we end up with a fraction, right? Where we have a top and a bottom, where the top represents the part and the bottom represents the whole, right? So what is the whole that we want to find? Well, we want to see $1, right? And $1 is what? 100 cents. So I'm going to put 100 cents. And then this is our part. So this is our part. This is our whole P and W. Our part is going to be the percent of $1 that is in his pocket, which is every cent that he has, which we calculated as 41. So as we know, if we take something out of 100, well, that's just the percent, right? So this means we have 41%, and the answer is D. So if you got D, good job. So pretty simple. For this next problem, if you guys want, you guys can unmute, maybe share your solution or type it to me, and then we can compare, right? Number 2, does anyone want to share how they did it?
Can I do that?
Uh-huh.
Can I do that? Can I do that?
Yes, yes.
So Johnny is 4-year-old younger than Dak. Dak is younger. Oh, no, Dak is so like it's a wait. So it's a like Dak is 3-year-old than in. So it's a 3 plus 15 equal 18, and then 18 minus 4 equal C is a 14. Is that correct?
Yep. So you said the answer is C, 14, right? And let's confirm that. So you said all you did was, Inez was 15 years old and Zach is 3 years older. Older means we add 3, right? So this is Zach's age, right here. That's 18. And then Jose is 4 years younger than Zach. So that's just 18 minus 4. And that is 14. Really simple. The answer is C. Nope. Okay, let's do this next one. All right. Now this one's a little bit more wordy. You have to read it pretty carefully. Does anyone have their solution? Okay, so a couple of people have said E. Yep. And so let's see why it is E. All right. So the following operations, which of them have the same effect on a number as multiplying by 3/4 and then dividing by 3/5? So multiplying by 3/4, we can just lay that out here. And then if we divide by 3/5, we know that dividing a fraction is the same thing by multiplying by its reciprocal, right? So the reciprocal just means we flip it. And if we get this, we can just cancel these out, right? These go to 1, and then we get 5/4. And which one of these matches? Well, if we divide by 4/3, well, none of the numbers match here, so that doesn't work. 9 over 20, that doesn't match either. 9/20 doesn't match. And here we have 5/4, right? So we have to be really careful when we see stuff like this, because even though it matches our answer, it does say dividing. And what does dividing by 5/4 mean? Well, that means multiplying by 4/5, right? And that's not what we want to do. We want to multiply by 5/4. So the answer is E. Good job. Okay. Let's get to problem 4. So what were your answers for this one? Okay, I have a couple C's. Yeah, mostly C's. All right, let's see what the answer is. So if we think of a number, add 1 to it, and double the result, well, this is just, we're sort of manipulating the number that he starts with, right? So what do we know? Well, we know that the original number is 6, right? Ben thinks of 6. And then he adds 1 to it and doubles the result. So 6 plus 1, and we can multiply all of this by 2. All right, so that's 2 times 7, and that's 14. Okay, and then now he gives the answer to his partner, which is Sue. So what number does he give Sue? Well, he gives 14, right? And then his partner then subtracts 1 from the number he has given and then doubles the result. So they subtract 1, or we can ignore this for now. Subtract this, and then they double the result. And that is 2 times 13, which equals 26. And that is C. So pretty self-explanatory. The thing is, we just have to make sure we're able to convert word problems into mathematical equations, right? We have to interpret what the question's asking us and then turn it into actual numbers that we can solve. So the answer is C. If you got C, good job. Also, if anyone has any questions about any of the questions that I did or any of the questions that we'll do later, feel free to unmute, ask. We have plenty of time. But we're going to move on to the next problem set. So problems 5 through 8. And then I'll give you guys another 10 or so minutes to do them. 5 more minutes. If you're stuck on a problem, feel free to move on. You can come back to it later. One more minute. All right, let's get to explaining these. So actually, some of these problems have different like solutions, right? There's a lot of different ways you can solve some of these, and that happens a lot when you get to the harder AMC problems. So it's even more important now to recognize which solution is the easiest so that you can save a lot of time. All right, so let's do number 5. Do we have solutions for number 5? Type them in the chat. Okay, we got a B, we got a C. We have an E as well. All right. Okay. Does anyone want to explain how they got what they got? If you typed an answer, do you want to explain why you got that answer? Okay, that's fine. Let's just go over it as a group then. So what we have here is a bunch of fractions, right? And we just need to find the smallest whole number that is larger than the sum. So whatever this equals, we want to find a whole number, right? So remember, whole numbers are numbers like 1 or 2 or 3, right? Decimals do not count as whole numbers. Fractions also do not count as whole numbers, right? So we want to find the smallest whole number that is larger than all of this. So how do we find the sum? Well, we just add them, right? Now there's two ways of doing this. Number one is we can add them as fractions, or number two, we can add them as decimals, right? So decimals, we can convert all of them to fractions. And honestly, the difference between those two methods is not really huge in this problem. So really, it's what you want to do. I'm going to do fractions because I do like using fractions more. So we have the first fraction, and we can convert that to an improper fraction, right? So 2 times 2 plus 1 is 5, right? We just converted this mixed fraction into an improper fraction. Can add this. Same over here, 3 times 3 plus 1 is 10. Same thing here. 4 times 4 plus 1, 17. And same here. 5 times 5 plus 1 is 26. Okay. Now, how do we add fractions? Well, we have to make sure the denominators are all equal, right? Before we can add them. So we need to find the least common, the least common multiple between them. So that would be, well, we could try maybe 4 times 5, that's 20. Well, does 3 go into 20? Well, it does not, so that doesn't work. Maybe we can do 30. 2 goes into 30, 3 goes into 30, but 4 does not. So let's try something like twice 30. Let's try 60. If we do 2 divided by 60, or 60 divided by 2, that works. 60 divided by 3 works. 60 divided by 4 also works. And so does 5. So we can put 60 and then convert all of these to a denominator with 60, right? So 2 times what equals 60? 2 times 30 equals 60. So you have to multiply the top by that as well. Do we all know how this works, right? Fractions converting to adding them. If you have any questions, I can explain this further. But we're just going to do this for the rest. How many 3's go into 60? 20. So we have to multiply the top by 20 as well. Get 200. Same here. 60 times 4 times what equals 60? Well, if we do some division, we get 15. So we have to do 17 times 15 here as well. I'll do that out here. 35. 155. And for the last one, how many 5's go into 60? Well, it's 12. So we have to multiply the top by 12 as well. This is multiplication. This is multiplication. All right, and we would add these all up, and we would get something like 150 plus 200 is 350. 350 plus 225, we can do that here, plus 312. 5 plus 2, 7. This is 11 plus 1 is 12. Carry over the 1. 6, 8, 9. And if you condense this all up, you would get 14 and 77 over 60. Okay. So this is a little bit more than, actually, let's do it even further. Okay. So if you don't know how I got from here to here, well, this is just converting, fractions and pulling out a whole from the fraction. So we can add 1 to here. And I would recommend, if you're not too quite confident in your fractions, you should review how to convert from, for example, mixed numbers to improper, adding fractions, and then converting back into mix. That would really help you on the AMC. But for now, this is our answer. And we can see that this is a little bit more than 15, but not quite 16, right? And so the question is, find the smallest whole number that is larger than the sum. So what number is larger than this? Well, it's just 16. So the answer is actually C. All right, that was a little bit complicated. And there's actually an easier way to do it, but it's a little bit more, roundabout. You have to think a little bit more about that. Does anyone have any questions, or do you want to share a solution that you did? No questions on the fractions? If you do, you can type it in chat and I will answer it. But let's move on to number 6. All right, what did you guys get for this one? Type it out in the chat. Okay, got a C, got 2 C's, a B, okay, so mostly C's, okay, and we got an E as well. All right, so let's go over this. Actually, before we do, anyone want to share the solutions? No? All right, let's do this then. Figures 1, or this is Roman numeral for 1. This is Roman numeral for 2, and this is 3. All right, so 1, 2, and 3 are squares. The perimeter of 1 is 12, and the perimeter of 2 is 24. And what we want to find is the perimeter of number 3. All right, so what is the perimeter of a square? Well, the perimeter of a square is, for example, for 1, it's this whole thing, all the sides added together, right? That's the perimeter. And for a square, we know that by definition, all the sides are equal, right? So, So this side right here, and this side right here, and this side are all equal. And there's 4 sides. So how do we find the side length of 1? Well, all we have to do is go to here, 12, and then we divide by 4. 3, right? So we know that each side is 3. Pretty simple. If we added all these up, we would get 12. All right, so let's do the same thing for number 2. Number 2 has a perimeter of 24. And it's a square. It has 4 sides. Therefore, each side has a length of 6. So we can write it as 6 and these 2 as well. So the goal is to find the perimeter of number 3. So this is number 3 here. And how do we find the perimeter? Well, we've been going from the perimeter to side length, right? And in order to find the perimeter, we would need a side length of number 3. So do we have a side length? Well, we have 2 parts of a side length, right? We have right here, this 3. And then we have right here, this is 6. So what happens when we add them all together? Well, this plus this is 9, right? So this side length actually is 9. And since it's a square, that means this is also 9. Oh, wow. Okay. This is 9. This is 9. This is 9. And so is this. And the perimeter is just adding them all together. So it's 9 times 4. And we get 36. So it's actually C. And if you got any other answer other than C, do you have any questions? I know, Ricky, you said A, and that is 9, which is partially true because we got 9, right, as a side length. But we have to remember to always look back on the question and see what it's actually asking us after you get your answer. So even though we got 9, we look back and we'll see that we want the perimeter, not the side length, right? And the perimeter is all of them combined, so we have to multiply by 4. All right, good job, guys. Next one, problem 7. Send in your solutions. Okay, we got a couple B's. All right, let's see. So at Cloverview Junior High, that's a high school, 1/2 of the students go home on a school bus. 1/4 go home by automobile, and 1/10 go home on their bicycles. The rest walk home. What fractional parts of the students walk home? Well, it says fractional. We're looking for a fraction. Really simple. And what do we know? We know how much of each of the students go on each, right? So 1/2 of the students by a school bus, 1/4 go by automobile, and 1/10 go home on their bicycles, and the rest walk home, right? So this key is in this word, the rest. So it's going to be all of this is going to make up everything that's not walking. And walking is just going to be 1 minus whatever is in here added together. Does that make sense? Because we have all of each, we have 1/2 of them here, 1/4 of them here, and 1/10 of them here, and we want to find everything else, so we subtract all of this from 1, because 1 is the whole, right? 1 represents all the students, 100% of the students, and these represent percentages of the students. Okay, so we're just going to solve this. This is actually 1 minus, we can do the same thing with the fractions. This is 2. Add it together, we get 17/20. Okay, so what's 1 minus 17/20? Well, you can do that in your head, or you can expand it. 1 is equal to 20/20, right? Fraction rules. And then we can subtract, and we get 3/20. And that is the fraction of the students walking home, right? 1 minus everything else. And so the answer is B. Good job if you got B. Okay. Question number 8. Let's send in your answers, please. Okay. We got much less answers for this one. We got a B. All right, well, let's do this. An American traveling in Italy wishes to exchange American money from dollars to Italian money, liars. If 3,000 liars is equal to $1.60, how much lyre will the traveler receive in exchange for $1? So we're converting from dollars to lyre, or from lyre to dollars, right? And the conversion that we have is 3,000 lyre per $1.6. That's our conversion. And what do we want to find? Well, we want to find how much lyre the traveler will receive in exchange for $1. So let's put the dollar on the bottom. That's what we want to know. And then on the top, we have, let's just say X amount of lyres, because that's what we're trying to find. Okay, and at this point, all we have to do is we're solving for X, right? We can multiply both sides by 1.0, which won't change much. So we're just left with this division. Let's divide 3,000 by 1.6. We get, can do some long division here. This is 1.6. Actually, I'm going to spare you guys the time, and you could always do this on yourself, but the answer to this is 1,875, and that's X. And if you plugged it back into here and then resolved it, you would get the same thing as well. So how do we find X? Well, all we did is we know that 3,000 lyre is equal to $1.6, and we want $1, right? So we divided this by 1.6, and we divided this by 1.6, right? That's what we did here. And we got 1,875. And so the answer is D. So if you got D, good job. And that is the end of the second problem set. And before we move on, I'm just wondering, would you guys like more time to work on the problems or less time? If you want, you can just message me. If you want more time, maybe I'm going too fast. Or maybe you have questions. And for the rest of you, you can get started on problems 9 through 12. Yep, already these look a lot harder. So make sure whenever you look at a problem, identify what you know and what you're trying to find. And that always helps a lot. Let's do a couple more minutes, maybe 3 or so. All right, guys, I'm gonna start explaining the problems now. I know we didn't have as much time, but we're running short on time, so we're gonna move forward. Let's do problem 9. So do we have answers for this? Anyone solve this one? Okay, we got a C. We got 2 C's. Okay. Let's do this. Now, we see that we have 3 circles, right? By looking at the diagram. And then we know that they're congruent circles. What does congruent means? Well, it means that they are the same size, they're the same area, and they're basically, if you move them next to each other, they would overlap. So these 3 circles are identical, P, Q, and R, and they're tangent to the sides of the rectangle, which means they, contact the rectangle at one point on each side. So the circle centered at Q has a diameter of 4 and passes through points P and R. All right, what does that mean? Well, which one's Q? This one, right? This circle right here. And then the center is right here. And it has a diameter of 4. So let's draw a line from one end of the circle to another, and this is a diameter. And we know that the diameter is 4. And if the diameter is 4 on a circle, if it's 4, then what is the radius? What is from here to here? That's radius, right? Well, it's just 4 divided by 2. So it's 2 and it's 2. So we know that the radius of the circle is 2. And remember, on a circle, any point from the center of the circle to the edge of the circle is equal to the radius. So if I drew a line directly up from here to the corner, this line would also equal 2 or have a length of 2. All right. So if we know that this is 2, and if we know that this is 2, then what is, for example, this length? Because we're trying to find the area of the rectangle, right? And what we want for the area of the rectangle is we want the width of the thing and the length. Or this could be the length and this could be the width, either way. And in order to find the whole width, well, we would need to find the length of a line that's drawn across here. So I know that this is 2, this is 2. What is this line? Well, we notice that the radius of Q is actually the radius of R because they're congruent, right? They're identical. And so we can say that this line is also R because it's a radius of R. Same for P. The radius of Q equals the radius of P. And since this circle is P and this is a radius, it's 2. So what's the width? Well, we just have to add all of these because they form a straight line, and that is 8. And then what is the length? Well, remember how we said earlier, if we drew a line straight up, it would also be 2 because this is also a radius, right? It goes from the center of the circle to the edge of the circle. So this is 2. Same if we drew down. This is also 2. So the length is just 4. And what we want to find is the area. And the area is just length times width, which equals 4 times 8, which is 32. So the answer is C. Cool. I know circles can sometimes be a little bit more complicated, so I would also study up on this if you're taking the AMC 8 because there are a good amount of questions with circles. And we actually had a video a couple months ago on circles. We had 2 videos actually. So if you want to go onto our YouTube channel, it's just Inland Empire Math Circle, and you can scroll down a bit. You'll find a video with circles in it. It'll give you everything you need to know. Next one, problem 10. Do we have any answers for this? And also, if you ever have a solution that's different from mine and you want to ask why it doesn't work or if it works, you can always just share that. Okay. Let's start on this. So what is the question? A jacket and a shirt originally sold for $80 and $40. So the jacket is $80 and the shirt is $40. During a sale, Chris bought the $80 jacket at a 40% discount. Okay, so 40% discount means that you're saving 0.4 or 40% of the price, right? So we can multiply that by 80. because remember, when we're going from any percentage, all you have to do is move the decimal point 2 times, and then that'll give you your decimal. So it's 40% is 0.4 times 80, and that gives you 32. If you did the multiplication, same thing for this. You have a $40 shirt at a 55% discount, which means you're saving 0.55. We move the decimal point 2 times, right? We get 0.55 times 40, and then we get 22. And if we add them together, this is the total price that he actually spent. And that's $54, right? That's how much he spent after the discount. Now, how much did he save? Or what was the percent of the total that he saved? Well, in order to find the percent of the total, we need to know the actual total, right? So how much was the original price? Well, it was just $80 plus $40. So that's $120. That was what he was supposed to be charged, but he got the discount, and instead he got the stuff for $54. So what is this? If you did the division, you would get 0.45, and we know that 0.45, if we move the decimal point, is just 45%. So the answer is actually A. Okay. Let's move on to the next one. Here we go. Number 11, do we have any answers for this one? Okay. D, okay. Okay. Yep, mostly D's. So this is one of the questions that you could easily get lost in the complexity, and you could easily go down a solution that's way too complicated. In reality, we don't actually have to do much math for this, right? We can just identify that since it takes Hector half the time, or Jane takes half the time it takes for Hector to walk, and they set off in opposite direction. Jane walks this way, Hector walks this way. And we need to know when is the first time they meet. Well, you could do some really complicated math to find it, but in reality, all we have to do is we can just draw out lines, right? We know that Hector takes double the time because Jane takes half the time, right? So for every 2 steps that Jane makes, Hector can only make 1 step. So let's actually just model that. Let's say Jane walks 2 steps. Hector is only going to walk 1. Jane walks another 2 steps. 1, 2. Hector walks another 1. And then again, Jane walks 2. Hector walks 1. Jane walks 2. Hector walks 1. Walks 1. And last one, well, guess where they meet? They meet at D, right? Super simple. Not really any math required. And if you can recognize this on the AMC, it would save you so much time. You could do this in probably 30 seconds, right? All right, let's move on to the last question. We don't have a lot of time left, so I'm going to try to go through this one complicated, which is really complicated, but I'm going to try to get through it really quick. So this one says that we're trying to find lucky years, and the definition of a lucky year is we have the month and the date that multiply up to the year, or the last 2 digits of the year. All right, so since it says the last 2 digits of the year, all we have to focus on is the last 2. 90, 91, 92, 93, and 94. And we have to find dates and months that multiply up to this, right? So how I would approach this is I would try to find the factors of 90. Remember, factors are just numbers that you can multiply by to get 90. So the factors of this, for example, are 1, obviously. You can you can divide this by 1. You can divide it by 2. You can do 3, 5, for example, 6, 9, and then 10. All right, so we can just try dividing this by any number, really. Let's try 10. All right, so if you divide 90 by 10, we get 9. So what does that mean? Well, if 9 is a factor, that means 90 is a multiple of 9, right? And we can actually use these 2 numbers. You can say that 9 times 10 equals 90. And then our date can just be 9, 10, 90. And this is a valid date, right? This is just September 10th, 1990. And so this is a lucky year. Now, don't get caught up and just put A because the question asks for not. All right, so we'll just do the same thing for these. I'll go through them real quick. The factor of this one is 7. By the way, how you would find the factors is you could, for example, maybe go down a tree, try out numbers. I would try out, for example, you could try 2 and find that it's not a factor. And then you could try 3, 4, or stuff that you can multiply this by. But in the end, you would find that we can only multiply this by 7 and 1. So the factors are 1 and 7. And then all we have to do is divide this by one of our factors. And for here, we get 13. And so our date, for example, can be something like 7/13/91, which is a valid date, right? This is July 13, 1991. All right, let's do the same thing for C. For C, we get maybe factors of this. There are more, but we're just going to try this because if we divided this by one of the factors, we get something like 23. And again, 4/23/92 is a valid date. And then we'll do this for 93 as well. Factors 1 and 3, maybe some others, but that's all we need for now. We can just try dividing this by a factor to see if it has a multiple. And it does. It has 31. So we have a 3 and a 31. We can arrange them like this. And that is a valid date, right? It's just March 31st, 1993. All right, let's try the same thing for 94. You have a factor of this. And if we divide 94 by 2, then we get, what is that, 47? And then you'll realize that no matter where we put 47, we could try putting it in the months, we could try putting in the date. It's not valid, right? Because we can't, for example, have 2/47. You can't have 47 months in a day. There's no month with 47 days. And so this is not a valid leap year, or it's not a valid lucky year. So we're saying that E does not work because its factors don't match up. Okay, so this one was complicated, right? Honestly, it's just repetition. We just find this, do the same thing for this, do the same thing for this, same thing for this, and same thing for this. And once you identify that this is how you're supposed to do the problem, then that's when the problem gets easier, right? Don't get like scared off by the amount of work that you have to do, because honestly, when you don't have to write it out, it's really quick work. So that was problem 12, and that's all we have time for today. We even went a little bit over. So if you guys want to go, you can head off, or if you have any questions, you can stay behind and ask on any of the questions. But thank you guys for coming.